Hi class, today we're going to look at standard NC.8.G.2, which is the use of transformations to define congruency. We're going to verify experimentally the properties of rotations and reflections that create congruent figures, and congruent meaning same size and shape. During the screencast, we're going to construct an irregular polygon and label its vertices. We're going to then find the image of the polygon under a 180-degree rotation. After that, we're going to create a mirror line and apply a reflection to the original polygon. And then finally, we're going to answer the question, is it possible for the image of the polygon after a rotation to correspond to the image of the same polygon under a reflection? But first, before we do that, let's just kind of look at what is an irregular polygon. And so first looking at regular polygons, we can see here that a square, of course, by definition, all sides are equal and all angles are equal. We can see the sides are equal to 3 and that the angle is equal to 90. An equilateral triangle, we can see that the sides are all 3 and that the angles on the inside equal 60 degrees. With the equilateral pentagon, we can see that all the sides are equal to 2 and that the angles on the inside are equal to 180. Now, an irregular polygon can have sides of any length, and each interior angle can be any measure. And so we see here that this is an irregular polygon, the rectangle, because even though the insides are equal to 90 degrees, we see that QP is equal to 4, SR is equal to 4, but the other two sides, RQ and PS, they're equal to 2. So that's what makes that irregular. With an isosceles right triangle, we see that the sides here NM is equal to 3, ON side is equal to 3, but the other side we see here, MO is equal to 5. In addition, on the inside, we see that two angles are equal to 45, but the third is 90 degrees. And of course, that is the definition of an isosceles right triangle. And the pentagon is similar as well with an irregular pentagon. We see that we have two of the sides that are equal to 2, two of the sides are equal to 3, 1 equal to 4. And on the inside, 3 of the angles are equal to 90, but the other two are equal to 135. So again, irregular polygon means you can have any side of any length, and each interior angle can be any measure. So the first thing we're going to do is we're going to use GeoGebra to construct an irregular polygon. And so we're going to come down to the polygons tool here and construct. And you can construct any polygon that has 3, 4, 5, 6 sides, 7 sides if you'd like. But I'm going to construct one that has 5 sides. And so we're looking here. And we have our label here, A, B, C, D, and E. I'm going to just turn off on the inside here with the settings so that this looks a little bit better, the label for the actual line itself. So we're going to turn that off. Then after doing this, we're going to rotate this pre-image. And again, this irregular polygon is called a pre-image. We're going to create an image that has a transformation of 180 degrees around the origin. And we see that we have it labeled here, the origin. So we're going to click on the irregular polygon, and then we're going to click on the origin that we're going to rotate. And then we're going to tell it to rotate 180 degrees counterclockwise. And so this being our pre-image, now we have our image A prime, B prime, C prime, D prime, E prime. And that again is rotated 180 degrees around the origin here. So 180 degrees. Question that I get sometimes is what happens if you reflect the opposite way there? So if we were to sit here and say 180 degrees counterclockwise, what would that look like? Well, it looks exactly the same. Doesn't matter if you go 180 degrees counterclockwise or 180 degrees clockwise, it's still going to look the same. Also, we can take this image and we can, or the pre-image, and we can manipulate it to move it around. And we can see that it will always be 180 degrees on the opposite side of our pre-image here. And so it kind of move it around. You can see there, it's going to be 180 degrees consistently at all times about that origin. Now what we're going to do is we're going to reflect it. We're going to reflect it across a line. The line that I'm going to choose to reflect it across here is actually going to be the x-axis. And so x-axis being right here, if we click this image and then click the x-axis, we see it reflects right around there. And we have here now A double prime, B double prime, C double prime, D double prime, E double prime. Again, the reason why is because the first time that we did our reflection or our 180-degree rotation, I apologize, that went from pre-image to image. And again, this is pre-image to image, and this is our second transformation. And again, I can kind of manipulate this, and we can see that no matter what, it's always going to be a mirrored image across the x-axis. I can go back, and we can actually also reflect that across the y-axis as well. Just going to delete this here. What does it look like if we reflect it across the y-axis? We select our point here, our pre-image, and then our y-axis, and we get our image here. Again, it is a mirrored image straight across from the y-axis, and again, we can manipulate that and kind of move this around, the pre-image around, and see that if B is 1 unit away, we see that on the opposite side here, B double prime is going to be 1 unit away. And the same thing goes with D prime here, any of these points here. If we look at D, we see that it is 4 units away from the y-axis here. Well, D prime is also 4 units away in the opposite direction there. And so that's kind of what we look at when we see those reflections. Um, the last question we have, is it possible for the image of the polygon after rotation to correspond to the image of that same polygon under reflection? Well, to do that, I'm actually going to switch screens here. We're going to look at this image here, and we have a right triangle. And again, this is an irregular polygon because our side here we see equals 1, this equals 2, this one's 2, so they're different, but also our angles are different. Right here we have a line which is actually the slope y equals negative x. So all I'm going to do here though is I'm going to take this, and so as we can see here, we have a right triangle, and what we're going to do is we're first going to rotate it like we did with the other image, the pre-image around the origin, 180 degrees. And again, it doesn't matter if you go counterclockwise or clockwise. And then we're going to take the same image and we're going to reflect it across what here is y equals negative x. Again, this is a slope. Y equals negative x. And so we have a negative slope here. Now, looking at it right now, it, of course, doesn't look the same. And again, the question is it possible for the image of the polygon after rotation to correspond to the image of that same polygon under reflection? But what happens if we maybe manipulate this a little bit and maybe turn this actually into an isosceles triangle? All of a sudden we see that they snap together, and we can actually, it is possible to create an image of the polygon after rotation to correspond to the image of that same polygon under a reflection. And again, this is an irregular polygon because we see that our sides here are 2, but CA is 3. Our angles here is 45 and 45. Our angle here is 90. So thank you so much. I appreciate your time, and I hope you have a wonderful evening.